Tides are a complicated phenomenon. Tides in the ocean are generated by the moon's gravitational pull, and they affect more than just how much room on the beach there is for a chair and umbrella. They're actually long-period waves that move through the oceans in response to forces exerted by the moon and sun, making their way towards the coastlines where they appear as the regular rise and fall of the sea surface. And they may also help to slow down the rate of global warming of the atmosphere, partially by forming a complex system of underwater waves that can help move heat into the ocean interior. That complex system of waves is essentially a different type of tide, called internal tides. NASA can see how internal tides move and flow in the ocean here. Across a long swath of the North Pacific Ocean sits the Hawaiian Ridge, a massive underwater structure high enough in a few places to reach the ocean surface and form the islands of our 50th state. The tidal currents that are generated by the moon's gravitation impact the Hawaiian Ridge, causing deep, dense water to be forced upward. Gravity and buoyancy forces then tug the water down and up again, creating oscillations. Those oscillations are internal waves. But since the waves oscillate at the tidal period, which is the time it takes for tides to complete one cycle, from high to low and back to high again in roughly 12 hours, we call them internal tides. Once generated along the ridge, these internal tides move away from it, both northwards and southwards, and can sometimes go as far as thousands of miles. Underneath the surface, the waves can be as big as hundreds of feet. But on the ocean surface, they're often only a few inches high, barely large enough to notice. Yet instruments on satellites, like altimeters, are capable of measuring those small surface waves, and NASA can predict internal tides based on years of compiled satellite data. The ocean is filled with underwater topography, from mountains to ridges to trenches, creating many sources of internal tides all over the global ocean, and giving rise to the many complicated patterns seen in this visualization. Although internal tides might seem insignificant, being only a few inches on the ocean's surface, they provide oceanographers with a unique way to map and study the much larger internal water motion. That water motion and subsequent mixing between warm, shallow water and cold, deeper water is thought to move heat from global warming of Earth's atmosphere down into the ocean interior. In other words, internal tides are an incredibly significant mechanism and have a sizable impact on the Earth's climate.